Nestled below the sensory cortex is the temporal lobe, which contains the auditory cortex. This region of the brain is responsible for processing everything we hear, as well as language interpretation. This is where we turn spoken language into something that has meaning. This region also plays a big role in producing language, spelling, grammar, sentence structure, syntax. All of these functions use a tremendous amount of cognitive horsepower. Just how much horsepower this region requires can be neatly demonstrated by a study that was done on distracted driving. In this study, drivers were placed on a closed course with a hands-free headset. While these drivers were negotiating the obstacle course, they were asked some simple true-false questions. The study was designed to isolate cognitive distraction, literally, how much of the brain is devoted to processing language. Drivers who participated made 37% more errors on the course while attempting to process language when driving. This study clearly demonstrates just how much cognitive processing power is devoted to the process of language and demonstrates just how much of an advantage we gain when we bring this region of the cerebral cortex into the fight. Finally, we move our way to the very back of the brain where we find the occipital lobe. This region is responsible for processing and interpreting everything that enters the brain through our eyes. This region is by far the most complex of the sensory processing systems. The number of neurons devoted just to visual processing number in the hundreds of millions and take up about 30% of the entire cortex, as compared to 8% for touch and 3% for hearing. Each optic nerve consists of 1 million fibers, compared to a mere 30,000 fibers in each auditory nerve. Visual processing is by far the most powerful system in the brain. That's the very reason that TV advertising can range in the millions for a 30-second spot, as opposed to the mere thousands for a radio spot. An often quoted statistic on the internet is that 1 minute of video is worth 1.8 million words. Now, this is not an actual research project. It's simply an extrapolation of the proverb that a picture is worth 1,000 words. There are 60 seconds in a minute, and a standard frames per second speed for video is about 30 frames. 30 frames per second times 60 is 1,800 pictures, times 1,000 words equals 1.8 million words. So the statement often quoted that 1 minute of video is worth 1.8 million words should be prefaced by the statement, if one picture is worth 1,000 words, then 1 minute of video is worth 1.8 million words. So how many words is a picture really worth? In Nicholson-Baker's 1983 investigation of the size of thought, he did an experiment in which he had participants describe in words the same information expressed in a single diagram or picture by others. What he found was that on average it took about 84.1 words to describe the same thing that could be described with a diagram or a picture. From this he deduced that a picture is actually worth 84.1 words, not 1,000. Using this calculation, 84.1 times 30 times 60 yields 151,380. Then 1 minute of video is more precisely worth 150,000 words, not 1.8 million, but still pretty impressive. It certainly explains why Budweiser makes so darn much profit from a 30-second video spot, doesn't it? Suffice it to say that if we are not using audio and video feed to infuse rational thinking into the cerebral cortex, we are leaving two very big dogs out of the fight. Not a good idea if we're going up against the amygdala. So how exactly do we bring these two big dogs into the fight? This I will explore in the next segment, part 4.